Good morning, children. It was nice to meet you all in the Zoom class yesterday. Hope you all also understood what I taught about centripetal and centrifugal force. Continue to listen to today's lecture. Today we are going to, I thought of revising first chapter quickly and solving some exercise questions which we have not done before. Okay, so it starts here, as you know. Definition of moment of force is here. Factors affecting moment of force is here. Formula for unit for moment of force is Newton meter. Formula will be force into perpendicular distance of force from point O. Then we have clockwise and anti-clockwise moments. Clockwise, if the rotation is in anti-clockwise, then it is called anti-clockwise moment. If it is in clockwise, then it is called clockwise moment. Anti-clockwise is always taken positive. Clockwise is always taken negative. Now this you have to remember. We'll be using it in some numericals. Anti-clockwise positive, clockwise negative. Then we had lots of applications based on the formula and based on this point that in all these examples, this will be the main reason. The turning effect of a body about an axis depends not only on the magnitude but also depends on the perpendicular distance. Main thing is, larger the perpendicular distance, less is the force needed to turn the body. Little bit of variation will be there in each application, but the main point, main reason will be this one. Then we came to the concept of couple. Definition: to equal and opposite parallel force not acting along the same line form a couple. Then when do you need a couple? When we require a larger turning effect. Okay, then okay, so these are some of the examples of couple. Then we have moment of couple. Formula for moment of couple: force, either force into perpendicular distance between two forces or couple arm. Then we had equilibrium. The main thing in this is conditions for equilibrium. First condition is for static. Second condition is for dynamic equilibrium. And the term algebraic sum of moments is important. Then principle of moments. Sum of anti-clockwise moments is equal to sum of clockwise moments. So this is all the theory that we have in this. Now we'll quickly do some exercise questions. Turn to page number 10. Page number 10. Question 15, 16 and 17 we'll be discussing now. Question number 15, 16 and 17. Okay. See the 15th one. A, B and C are three forces, each of magnitude 4 Newton, acting in the plane of paper as shown in figure. The point O lies in the same plane. What force has the least moment? Now, there are three forces: force A, force B, force C. They're all acting about a point O. Okay. So now the first question is, which force has the least moment about O? Give reason. Now, whichever is at a closer distance. Now, all of them are of same magnitude. Force is the same. So, we know that moment of force is force into, moment of force will be force into perpendicular distance. Now, force is same in all the three cases. So, it's the perpendicular distance that's going to affect. So, whichever is closer, least means whichever is closer, that will have least moment about O. So, C. Okay, force C will have least moment. The reason will be the perpendicular distance between them is the minimum. Which force has the greatest moment about O? For this, we have to see the maximum, the one with maximum distance. That will be force A. Name the forces producing clockwise and anti-clockwise moments. Now, if you see A, it is going like this. So, that is clockwise. B is also clockwise. C is anti-clockwise. So, A and B are clockwise. C is anti-clockwise. Now, what is the resultant torque about the point O? So this is very important and you should be able to solve it. Now, so what is the moment of force due to force A? Moment of force due to force A will be force into perpendicular distance. Force is given as 4 Newton. Perpendicular distance will be 0.9. That will be 4 nines are 36 or 3.6 Newton meter. Then moment of force due to B will be again 4 into 0.8, that is 3.2 Newton meter. Then moment of force due to C will be 4 into 0.6 meter. 6 fours are 24, that is 2.4 Newton meter. So now they have asked you to find the resultant. Whenever resultant is asked, then you have to consider the direction, or the sign should be taken into account. So already in the while reading we saw anti-clockwise moment is positive and clockwise moment is taken as negative. So we know that A and B are clockwise, so they will be negative. Put a minus sign before them, and C will be positive. So the resultant will be minus 3.6 minus 3.2 plus 2.4. So minus 6.8 plus 2.4, that will be minus 4.4 Newton meter. Or you can write in the next step 4.4 Newton meter in clockwise direction or clockwise moment. Either you write it as minus 4.4 Newton meter or you write 4.4 Newton meter within bracket clockwise moment. So this will be the answer. So this type of question comes often, so better it will be good if you understand it and will be able to solve it clearly. Okay, so be careful with the signs. When resultant is asked, signs are very important, and then you solve it. If your answer comes in negative, then it is clockwise moment. If it was positive, it would have been anti-clockwise moment. Okay, 16th one. The adjacent diagram shows a heavy roller with its axle at O, which is to be raised on a pavement XY. If there is friction between the roller and pavement, show by an arrow on the diagram point of application and the direction of force to be applied. Okay, so it has to rotate about, okay, it has to raise on this pavement. That means it has to rotate about X. Okay, it has to roll like this and come here. So about X it has to rotate. So we have to see from X which will be at a maximum distance. So from X, the diametrically opposite point will be this. So this will be at a maximum distance. Okay, so we want the force to be minimum. Okay, so to keep the force minimum, we want to increase the perpendicular distance. So this is the point which is at maximum distance, and then the force should be in this direction. Okay, the force should be in this direction, then it will be rotated. So you have to rotate it in clockwise direction. So this force will rotate it in clockwise direction and make it rise into the pavement. Okay, that's all. You just have to know how this comes. Then coming to 17th question, a body is acted upon by two forces, each of magnitude F, but in opposite direction. State the effect of force if both forces act at the same point of the body. So a body is acted upon by two forces, each of magnitude F, but in opposite direction. State the effect of force if both are acting. So both the forces F are acting at the same point of the body. Now what will be the effect? Now this will cause a clockwise and this will cause a, now about resultant moment will be 0. Moment of force will be 0. Why? Perpendicular distance between axis of rotation and them will be 0. Therefore, moment of force will be 0. So, resultant will also be 0. And there will not be any motion. Resultant will be 0. No motion. Okay. Now, state the effect of forces. Effect of forces means you have to write whether it will move or not move and in which direction. So, here the answer will be resultant force is 0. So, it will not move. Now, the two forces act at two different points of the body at a separation r. So, first itself they said it acts in opposite direction, but in the B case, they act at two different points of the body at a separation r. So, one is acting here, one is acting here, and the separation between these 2 points is r. So, this forms a couple. Okay, this forms a so resultant force will be 0 because this is, if this was plus 4 Newton, this will be minus 4 Newton and they'll get cancelled. Resultant moment of force will be this, because this forms a couple, either force into couple arm. So that will be F into R. So the resultant moment of force will be F into small r. Then what will be the effect of it? This will rotate the body in clockwise direction. So this will tend to rotate like this. This will tend to rotate like this. Finally, this will rotate in clockwise direction about the midpoint between the two forces. Now, something pivot will be somewhere here. About this will be able to rotate in clockwise direction. Okay. So this is how you have to solve. Okay. In the first case, no resultant force, no resultant moment of force. In the second case, it forms a couple. So your resultant is this and it makes it rotate in anti-clockwise direction. So this is how, these are 3 tough questions that I have solved for you. And so this is just a practice. You can keep trying the other numericals also. Other questions, the theory questions. Try finding the answers of the other questions, but these 3 were the complicated ones. Now, coming to numericals, I remember I solved few in the class before the lockdown and I gave some homework. I don't know how many of you were able to do it, but as a quick revision, I'll be doing the last 3 sums, 16, 17 and 18. Turn to page number 12. We'll be doing 16, 17 and 18 numerical. So, let's start with numerical number 16. So, a uniform half meter rule can be balanced at the 29 centimeter mark when a mass of 20 gram is hung from its one end. Draw a diagram of the arrangement. Find the mass of the half meter rule. So, it is written, it's a half meter rule. Okay, so draw a rule and what should be the length of it? 50 centimeter. Half a meter means 50 centimeter. Balanced at 29 centimeter mark. So 25, middle is 25 somewhere here. So 29 will be here. So it is balanced at 29 centimeter mark. So this is your 0 centimeter mark and this is your 50 centimeter mark. Now, when a mass of 20 gram is hung from its one end. Now, one end can be this end, either this end or this end. Now, how to decide which end? Okay. Now, before deciding that, now, there are 2 cases generally. If a body is not pivoted at the center, now in this case, the center will be 25. So, if you remember, by chance, if the body would have been pivoted at center, 0, 50 centimeter, and if it was pivoted at 25 centimeter, okay, generally the weight, okay, there's the force, weight is also a force that is acting on a body. As we studied CG, the center of gravity will always be acting, or the weight of the body will be acting from the geometrical midpoint. So, if it was hung from here and the weight will also be acting from here, then moment of force due to the weight of the scale. W will be 0. Why? This is the pivot, means this is the point about which it has to rotate, and this is the point from which W is acting. So what is the distance between these two? 0. Because the distance between them is 0, moment of force will also be 0. So in such cases, you need not worry about the moment of force due to weight of that particular thing. But in cases like this, where it is not pivoted at center, it is pivoted at some other point. So the moment you see that it's pivoted at some other point, what you do, at 25 centimeter, you just put like this, W. The weight will be acting from 25 centimeter. Now why should we consider? Because there is a distance between them. Okay, there is a perpendicular distance between the pivot, that is axis of rotation, and the point from where force is acting. So we will consider this in this case, but in the previous case, if it would have been pivoted from center, we would not have considered it. Okay, so the conclusion is, in the sense, the first conclusion that we get is that the weight is a force which is acting, will be acting definitely from the middle points. There is a force here. So this will have an effect to produce anti-clockwise moment. Now, the other weight that I suspend, okay, the 20 gram mass, okay, they have given mass of 20 gram is hung from one end. So I have to hang it from this end so that it will produce a clockwise moment, and then it will be balanced. There is a chance for this to be balanced. If I put this 20 gram also in this side, now both will become anti-clockwise, and then it can never be in equilibrium. Definitely this rod will be bending this side. Okay, both the forces will be this side, and definitely this side will be down and this side will be up. They will never be in equilibrium. Okay, so hope you understood this question. If it has to be balanced, one has to be on the left and the other one has to be on the right. Okay, this is the diagram. Then find the mass of half meter rule. We are asked to find the weight basically. So first we will find the distance. The distance between this is 4 centimeter, and the distance between this is 50 minus 29, that is 21 centimeter. So our anti-clockwise moment will be W into, so this is your anti-clockwise, W into 4. Okay, and clockwise moment will be 20 gram force. Okay, 20 gram, or you can take the force to be 20 gram force multiplied by the distance is 21. Okay, so this much gram force centimeter, this much gram force centimeter. Now so anti-clockwise moment is equal to clockwise moment when it is balanced. So W into 4 will be equal to 20 into 21. So W will be 20 into 21 upon 4. So 5, 1 5 are 5, 2 5 are 10. So 105 will be the gram weight of it, or mass will be 105 gram. So this is a very important question. As I told you before itself, children, one numerical definitely will come from this exercise. In your question paper, section B, that is question number 5, you'll have one of these questions. Okay, this sum itself has come couple of times, and yeah, so please understand the concept and try to solve it. As you're watching, after watching, please pause it and try to solve it by yourself in your notebook. That will help you. Now let's go to the 17th question. Uniform meter rule of mass 100 gram. So this is a meter rule. So 100 centimeter, mass 100 gram, balanced on a fulcrum at 40 centimeter mark. So here will be the 40 centimeter mark, 0 centimeter, and this is the 100 centimeter. So it is balanced at 40 centimeter mark. So your pivot should be there, and its mass is 100 grams. So where will that be acting? From 50 centimeter, because it is pivoted at some other point, weight will be acting from the center. So we can write W is equal to 100 gram force. Mass is given as 100 grams, so you can take W is equal to 100 gram force. By suspending an unknown mass M at the mark 20 centimeter. So from 20 centimeter, they are suspending an unknown mass M. Suspending an unknown mass M. Now, we have to find the value of M. Okay, so as usual, this will be anti-clockwise moment, this will be clockwise moment. So anti-clockwise moment will be, so now let's find the perpendicular distance. 40 minus 20, that is 20 centimeter. Okay, you need this distance. Don't take this or this, you need this distance. So subtract them and find the in-between distance. So this will be 50 minus 40, that is 10 centimeter. So your anti-clockwise moment will be M into 20, M into 20, and your clockwise moment will be 100 into 10. So M into 20 is equal to 100 into 10, or M will be 100 into 10 by 20. So this will be 5 into 10, that will be 50 gram. Mass I've written, so you can just write it as 50 gram. So the value of M is 50 gram. Second part, to which side the rule will tilt if the mass is moved to the mark 10 centimeter. If you're going to shift this to 10 centimeter, so what will happen? This distance will increase. Therefore, this moment will increase. So, anti-clockwise moment will be greater than clockwise moment because it will increase. So, it will become greater than clockwise moment. So, what will happen? This will be more. So, it will tilt like this, right? This part will come down, this part will go up. So the answer is given. It will tilt on the side of mass M. It will bend on this side and will rise up on this side. Third part, what is the resultant moment now? When it is being shifted to 10, what is the resultant moment? So in that case, anti-clockwise moment will become 40 minus, so in this case the distance will be 30 centimeter, right? So M into 30, clockwise moment as usual 100 into 10. So M into, sorry, mass we have already found as 50 gram. So this is 1500, this is 1000. Now anti-clockwise moment should be taken positive and clockwise moment should be taken negative. So the resultant will be plus 1500 minus 1000, that will be 500 gram force centimeter, and it will be in positive, so it is anti-clockwise direction. Okay, anti-clockwise moment. Either you write it as plus 500 gram force centimeter, or you write 500 gram force within bracket anti-clockwise moment. How can it be balanced by another mass of 50 gram? So now, so we saw that it is going to tilt in this side. So to balance it, I have to add another mass this side, of course. Okay, so somewhere I have to put a 20 gram mass. So I have to put 50 gram mass. I have to put, first conclusion you will take it, it has to be put on this side because it is already tilting here. This side moment of force is more. To increase this side's moment, I have to put this, hang this 50 gram from the right side of the pivot. That's my first conclusion. Then you take this distance to be x, and then you have to find the value of x. So how are we going to do it? So same way, anti-clockwise moment will be 20 into anti-clockwise moment is 1500, and then clockwise moment due to this will be 1000. So clockwise moment due to this will be 50 into x. So 1500 is equal to 1000 plus 50x, or 50x is equal to 500, or x is equal to 500 upon 50, that is 10 centimeter. So 10 centimeter from the pivot. That means it has to be also hung here. So your 50 gram mass also has to be hung from 50 centimeter mark. Okay, so the answer will be by suspending the mass 50 gram at the 50 centimeter mark or 10 centimeter to the right of the pivot. Any way you can write. So this is also one of the complicated sum, and hope you understood it. Now quickly let's do the 18th one. So it is given that a uniform bar of length L is being supported at its ends and a W and loaded by weight W kgf at its middle. So this is the middle point. So the total length is L. So this will be L by 2 and this is L by 2. Now the reaction here is R1 and the reaction here is R2. In equilibrium, find the reaction R1 and R2 at its ends. Now at a time, it can't have both the fulcrums, either this or this. So in the first case, if you take this as fulcrum, okay, if A as is the fulcrum, then moment of force due to R1 will be 0. Why? Because this is the fulcrum and force is acting here, perpendicular distance is 0. So moment of force due to this will be 0. Now, whereas moment of force due to W, weight W will be W into perpendicular distance, that is L by 2. Okay, so this will be your anti-clockwise moment and R2 will be this will be clockwise and this will be anti-clockwise. Okay, this will be clockwise. And then moment of force due to R2 will be R2 into L by 2. Okay, so now anti-clockwise moment is equal to clockwise moment. So you will be writing W into L by 2 will be equal to R2 into L by, when you take R2, the distance between the fulcrum and this force R2 is L. It's not L by 2, it's L. When you're taking W, the moment of force due to W will be W into L by 2, but moment of force due to R2 will be R2 into the whole distance because the fulcrum you're taking is here. So, W into L by 2 will be R2 into L. L and L will get cut. So, your R2 will be W by 2. The same way, you take B as fulcrum. If B is the fulcrum, so same way you can do it. Moment of force due to R2 will be 0. Moment of force due to R1 will be the clockwise moment, and this will become anti-clockwise moment, and then you equate it. Again, you will get R1 is equal to W by 2. This is how you get the answer. So children, try to complete this whole exercise. Whatever sums are left out, please try to complete, and if you have any doubt, please clear it in the next Zoom class because it's very, very important. Also, try and solve this exercise as much as possible. Plus, in yesterday's Zoom class, I told you to try question number 10, 12 and 13. Please try them also. Thank you so much.